Alright, so welcome to 8.5, solving rational equations, and basically we're just going to solve rational equations, and you will see some application problems here, so keep that in mind. Okay, so a rational equation is an equation that contains one or more rational expressions, which means you'll see something like a fraction with an x in the bottom. Oh no! Deal with it. You'll be fine. Multiply by the LCD to get rid of the all rational expressions. So this is the important part. You need to get rid of the fraction. That will be your step one. You will multiply. It's not a hard thing to figure out. You can do this. So here's our first example. X plus 8 over x equals 6. Now what that means is here we need to get rid of the 8 over x. We need to get rid of the x on the bottom. How do you get rid of a fraction? You multiply by that denominator. Least common denominator, in this case x, will do that. Now if you're going to do it to that term, you need to do it to all of them. You have to be fair. So I'm going to say x times x is x squared. X times 8 over x, those x's will cancel out, leaving me just an 8. And then 6 times x is 6x. Oh look, this looks like a quadratic. So what you need to do is move the 6x over to the other side, and I'll have x squared minus 6x plus 8 equals 0. And then I will say factor, because I'm seeing an x squared and I'm seeing a minus plus, I'm going to try to do minus minus equals 0. And let's see, two numbers that multiply to give me an 8 and add up to 6. Could it be 2 and 4? Yes, it could. So there you go. Factor that, set both of those equal to 0, and that means x is equal to 2 or x is equal to 4. Now again, you should check your answers to make sure both of them can work, because if you put one into say either one of those and it gives you a 0 in that denominator, then that's a solution that doesn't work. When a solution does not work, we call that an extraneous solution, or no solution. Sometimes it seems like they come up with new terms just to kind of make y'all confusing. But we'll try to use that terminology that they're using here, extraneous solution, which means it doesn't count. All right. So let's look at another example. In this example, I have 3x over x minus 3 equal to 2x over x minus 3. So what I need to do is try to figure out what I can multiply by to get rid of the fraction. I don't necessarily want to straight cross multiply, because that could make it actually more confusing. So in this case, I see that both of them are x minus 3, so if I multiply by an x minus 3, I will get rid of the fraction and basically leave it as 3x is equal to 2x plus 3. Then I can go ahead and subtract my x, get x is equal to 3. Now, this is what I mean by testing out the problem. If you put that 3 in place of the x and say here, and say 3 minus 3, you get an answer of 0. If you get an answer of 0, then that means you can't, because that would make the denominator undefined, so it can't count. So I cannot let x equal 3. So that's what is an example of an extraneous solution. Now, not always is going to be just one answer. Maybe I get two answers and one of them works, but one of them doesn't. So you need to make sure you keep that in mind. Okay, so here's a really complicated example. I'm kidding, it's not that complicated. 2x minus 9 over x minus 7 plus x over 2 equals 5 over x minus 7. The first thing to do, and again, it helps if it's already factored out, which in this case it is to find the least common multiple, or least common number. What you're going to multiply by to get rid of those fractions. Well, I see there's an x minus 7 and a 2. So that's what I want to multiply by. I don't need to multiply by both x minus 7s, just one. And a 2. And I'm going to write them under each one of these fractions so you can kind of see what happens here. Notice that here I'm going to say this times the x minus 7 times that first term. And the x minus 7's cancel out, leave me a 2. That 2 needs to multiply the numerator. So 2 times 2x minus 9 is 4x minus 18. Then I'm going to do the x minus 7 times 2 to the second term. There, the 2's cancel out. So I need to do x minus 7 times x, which is x squared minus 7x. Then I'm going to do, again, the x minus 7 times 2 to the last term. The x minus 7's cancel out, leave me 5 times 2, which is 10. And again, this looks like a quadratic function, combine my like terms, get the 10 over to the other side also, and when I do that, I will end up with x squared minus 3x minus 28 equals 0. And again, because 4 minus 7 is negative 3, move the 10 over, it'll be negative 18 minus 10, which would be negative 28. Minus minus is a plus minus, x plus, x minus, and should be 4 and 7. 4 minus 7 gives me negative 3. Plug those in, solve, you get x equal to negative 4 or x equals 7. Now, again, check both answers. If either one of those goes into the original denominators and gives you an answer of 0, that one is extraneous. That means the other one is the right answer. So put 7 in place of the x, you get 0. So x equals 7 is extraneous. That means your answer has to be only x equals negative 4. Okay, so one more example dealing with this, the rational equations, and then I think we're looking at some application problems. 6 over x plus 5 over 4 equals negative 7 over 4. My least common multiple is 4 times x. Notice all I'm doing is multiplying the two denominators, the two different denominators, or the two unique denominators. So that when I do my steps, the 4x, the x's will cancel, leave me 4 times 6, which is 24. The 4's cancel, leave me 5 times x, which is 5x. And the 4's cancel, leave me negative 7 times x, negative 7x. Move the 5 over, I got 24 is equal to negative 12x, divide by negative 12, and I've got x is equal to negative 2. Plug that in anywhere and it's going to work, so there won't be no zeros in the denominator, so your answer is fine, negative 2. Okay, so for my first application problem, we're dealing with some motion here. I don't have a better way of telling you this than just here's that problem. An express train travels 150 kilometers in the same time that a freight train travels 100 kilometers. The average speed of the freight train is 20 kilometers less than that of the express train. Find the speed of each train. So I'm going to do the problem on the next slide, but make sure you've got this written down, or you know what the heck we're talking about here. Okay, so the first thing we would do is let's create a little box for these type of problems. Rate, time, distance, because everything moves in a speed, travels a certain time, and goes a certain distance. Now, I don't know the rate of the freight train or the express train, but I do know that it had a speed, so I'm going to say that's x. And the freight train was 20 less than that, so x minus 20. The distance that the express train went was 150, the freight train went 100. Now, distance is equal to rate times time. So that means that if I divide the distance by the speed, I get how much time. So that's what I'm writing here. Rate times time is equal to distance. It's a basic formula. So if I divide the distance by the rate, the speed, I get that. Now, since they're equal, we know they travel the same amount of time, I can set that middle column, 150x, divided by equal to the 100 over x minus 20. Now this is one where it would be easier to cross multiply, and so that's what you're seeing me do. And then from there I can combine my x's, and then I can divide, and I've got my speed of the express train. So here I've got negative 3,000 is equal to negative 50x, so x is equal to 60 kilometers per hour. So the express train was going 60 kilometers per hour. That means the freight train going 20 miles or 20 kilometers less is going 40 kilometers per hour. You will do some application problems like this, so be prepared for those. Okay, and then there are word problems. And on this word problems, I'm going to use an example number 4 on page 603, which is talking about, say, somebody that's doing a job. In this case, Jason trying to clean a large aquarium tank, and he gets some help from Lacey. And this is how we set up these problems. When they're word problems and people together, we do it like this. The time that it takes them to do it together is up in one fraction. Time it takes one person alone is the denominator. Time it takes them together, again, is the second numerator. Time alone for the second person is the second denominator. And this will always equal 1. So if you look at this, Jason can do the job in 6 hours. Together, it says that they can do it in 3.5 hours. So I'm going to put 3.5 for both of them on the numerators. I don't know how long it takes Lacey to do it by herself, because that's what the question is asking, is equal to 1. So then we do our least common denominator, which is 6x, and basically we're going to almost kind of cross multiply. 3x x times 3.5, 3.5x. 6 times 3.5 is 21. But then I still need to do 3.6x, because if I'm multiplying this by 6x, I need to multiply here by 6x. So equals 6x. So notice the two denominators multiplied over here. Combine your like terms and then divide. And so I got the 2.5 by subtracting 3.5 from 6, and I get about 8.4 hours. That's 8.5. If you do have any questions, feel free to send it to me on Edmodo. And I'll see y'all on Monday.